Hi, the name of this Blender video tutorial is TransformConstraints CopyRotation. One of Blender's many transform constraints is called CopyRotation. The CopyRotation constraint allows the rotation settings for one object to control the rotation settings for another object. The CopyRotation constraint, I have modeled in my Blender scene 3 gear-like objects, named Gear 1, Gear 2, and Gear 3. Gear 1 and Gear 3 are bluish in color, and Gear 2 is reddish in color. All 3 gear objects have a black dot on one of the teeth to give you a better sense of the gear's speed and rotation. I've also added an empty object to the scene named ControlEmpty1. Now, although it's not strictly necessary, I will use this ControlEmpty to control the rotation of the gear objects. I have animated this ControlEmpty to complete one revolution of 360 degrees around its y-axis in 100 frames. I'll play this empty animation. In the graph editor, I have edited the animation curve for the empty to exhibit a vector or straight line animation. The empty rotates 360 degrees around the y-axis at a constant speed. I'll stop the animation timeline and go back to frame number 1. Now, before I add any CopyRotation constraints to the gear objects, I must first complete a very, very important preliminary step. That is, I need to apply the existing rotation settings on all of the gear objects. To do this, I will select a gear, in this case gear number 1, and then press Ctrl-A. I will then select Apply Rotation. Applying the rotation resets the rotation settings for the object to X, Y, and Z rotation equals 0, but it retains any rotations that may have been previously set to the object. This is important, for instance, to gear number 2, which I previously rotated 12.5 degrees around the y-axis so that the teeth of the gears mesh properly. I will apply the rotation to gear number 2. Ctrl-A, Apply Rotation. If we look at the Properties panel for gear number 2, the rotation settings are at 0, even though this gear was previously rotated 12.5 degrees around the y-axis. I will apply the rotation for gear number 3. I'll then select the gear number 1 object and go to the Constraint panel and add a CopyRotation constraint. In the target box of the Copy Constraint panel, I'll select the ControlEmpty1 object. I want Gear 1 to copy the Y rotation of the ControlEmpty1 object, so I will uncheck the X and the Z copy rotation checkboxes. I'll then play the animation. Taking its Y rotation settings from the ControlEmpty1 object, the Gear number 1 object rotates around its Y-axis 360 degrees in 100 frames. I'll stop the animation and go back to frame number 1. I'll select gear number 2 and add a CopyRotation constraint. In the target box, I'll select the ControlEmpty1 object. I will uncheck the X and the Z CopyRotation checkboxes, and I'll play the animation. Notice that gear number 2, like gear number 1, rotates around its y-axis 360 degrees in 100 frames. However, logically, it needs to rotate in the opposite direction. To do this, I will check the Invert checkbox for the Y copy rotation setting. Now gear number 2 rotates in the opposite direction of gear number 1. I'll stop the animation timeline and go back to frame 1. I'll select gear number 3 and add a CopyRotation constraint. In the target box, I'll select the ControlEmpty1 object. I'll uncheck the X and Z CopyRotation checkboxes, and then I'll play the animation. Like the other gears, gear number 3 rotates 360 degrees around its y-axis over 100 frames. I'll stop the animation, and I'm going to go to layer number 2. Now here I have 3 more gear objects, named Gear 4, Gear 5, and Gear 6. I also have another empty object called Control Empty number 2, to which I've added an animation of a 360-degree rotation around its y-axis over 100 frames, the same as I set for the Control Empty 1 that was used on the other layer examples. Gear number 5 is twice the size of either gear number 4 or gear number 6. Gear number 5 has 14 teeth around its circumference, while gears 4 and 6 have 7 teeth. Now before I add any copy rotation constraints to the gear objects, I'll complete the very important first step of applying the existing rotations to each gear. Select, Control A, Apply Rotation. Select, Control A, Apply Rotation. Select, Control A, Apply Rotation. I'll then select gear number 4 object and go to the Constraint panel and add a Copy Rotation constraint. In the target box of the Copy Constraint panel, I'll select the Control Empty 2 object. I want gear 4 to copy the Y rotation of the Control Empty 2 object, so I will uncheck the X and the Z Copy Rotation checkboxes. I'll then play the animation. Taking its Y rotation settings from the Control Empty 2 object, the gear number 4 object rotates around its Y-axis 360 degrees in 100 frames. I'll stop the animation and go back to frame number 1. Gear number 5 is twice the size of gear number 4 and has twice the number of gear teeth. Logically, the speed of the rotation for this gear should be 1/2 that of gear number 4, and its rotation needs to be in the opposite direction. I'll select gear number 5 and add a Copy Rotation constraint. In the target box, I'll select the Control Empty 2 object. I will uncheck the X and Z Copy Rotation boxes and checkmark the Invert checkbox for the Copy Y rotation. This will make the gear rotate in the opposite direction as the Control Empty 2 object. I will then set the Copy Rotation Influence slider to 0.5. This means that the speed of the rotation will be 1/2 of that of the Control Empty 2 object and that of gear number 4. I'll then play the animation. Gear number 5 rotates in a counterclockwise direction at half the speed of gear number 4. Since gear number 5 is twice the size and contains twice the teeth as gear number 4, the gears mesh properly at this speed. I'll stop the animation and go back to frame number 1. I'll then select gear number 6 object and go to the Constraint panel and add a Copy Rotation constraint. In the target box of the Copy Constraint panel, I'll select the Control Empty 2 object. I'll uncheck the X and Z Copy Rotation boxes and then play the animation. The 3 gears now rotate and their teeth intermesh logically.